Radius of convergence of a power series. Let's suppose that the function fx is equal to the power series anx minus c power n for each real number x, such that x minus c absolute value less than r. This means x minus c between minus r and r. And if we add c to each part, so it will be c minus r less than x less than c plus r. So x in the interval, c minus r, c plus r. So this interval is called interval of convergence. So in this interval, the real number c is called the center of the interval, and r, the radius of the interval. So let's explain what's the meaning of center and radius of interval in this example. Let's take here the interval 1 minus 2, 1 plus 2. So I will suppose C1 and R2. So the interval of center 1 and radius 2 will be written as 1 minus 2, 1 plus 2. So it's minus 1, 3. So this interval in blue. So here the 1 in the middle is C. So for this reason, it's called center. And this distance is 2, and this distance is 2. So 2 is the radius of the interval. We have this rule about how to calculate the radius of interval of a given series. So let's suppose that we have series, power series sigma an x minus c power n converges using ratio test. So if we, the ratio test, if you remember, it was if we have a term here, general term, Bn, for example, we suppose this term, Bn. So what was the ratio test? The condition was the limit of Bn plus 1 over Bn must be approaches a number L less than 1. If the limit when n goes to infinity is a number less than 1, so it converges. Remember that in the condition of ratio test, Bn must be positive. So this series is not positive in general, so let's take it in absolute value. After that, if this is an absolute value converges, so it will, so without absolute value will converge also. So let's take the limit of the general term in for n plus 1 over the general term for n. So now I can delete this term over this term, and after deleting, I have x minus c absolute value. I have this term. So let's suppose that this limit is L. So the condition was that this limit less than 1. If it's less than 1, so converges using ratio test. So L times x minus c less than 1. So now we have x minus c absolute value less than 1 over L. So I will call this number R, the radius of convergence. So for any given series like this, how to find the radius of convergence? Let's take limit of an plus 1 over an when n goes to infinity. An is given here. So if the answer is L, I will take it in absolute value if these terms are not positive. After calculating L, take 1 over L as R. So 1 over L will be the radius of convergence, and the interval of convergence will be C minus R, C plus R. This is the interval of convergence. Let's take some examples. find this radius of convergence and interval of convergence of the following series. The first one, we know this series, it's a geometric series, and we know before that, so we can solve using two methods. We can write this is geometric, so it's 1 over 1 minus x, and this is correct for x between -1 and 1. So now we know the interval of convergence, and we know the radius. The radius, I take the ending minus the beginning, so it's 2 over 2, it's 1. So the radius of convergence r equal 1 and c equals 0. If you take c minus r, c plus r, so 0 minus 1, 0 plus 1, so it's minus 1, 1. But let's verify that using our rule that let's take here, what is the term an here? It's 1. So let's take the limit of an plus 1 over an when n goes to infinity. It's the limit of 1 over 1. So it's 1. So this is L. So what is R? R is 1 over L, also 1. What is C? The center. We have here x minus 0 power n. So it's x minus 0 power n in my sigma. So this 0 is C. So the center of the interval is C is 0. So finally, after calculating C and R, so we have C minus R, C plus R. This is the interval of convergence. So it's 0 minus 1, 0 plus 1. So it's minus 1, 1. Let's take another example. Now here, this is AN. So let's calculate limit of an plus 1 over an when n goes to infinity. So let's write an plus 1, it's 1 over n plus 1 power 2 times 2 power n plus 1 divided by 1 over n power 2 times 2 power n. So let's delete here this term with this term. We will have 2 here. And we have limit here. Let's delete the limit instead of repeating the limit each time. We will write the limits in the end. So it's n over n plus 1 power 2 times a half. So what is the limit of this term when n goes to infinity? So this term here, n over n plus 1, goes to 1. 1 power 2 times a half. So it's a half. A half less than, no, a half, it's the number L. So I will call it L. So here, remember that x minus c, what is c? C is 3 here. X minus 3 absolute value less than 1 over L, which is R, which is, what is 1 over L? 1 over a half, so it's 2. So I have this formula. Now the radius of convergence is 2, and the interval of convergence is x minus 3 less than 2. I can write this as from 3 minus 2 to 3 plus 2. This is the interval, so it's from 1 to 5. Let's take this example now. Let's take this term power n plus 1. So the term for n plus 1 over the term for n. So I am using ratio test now. Ratio test. So this term must be in absolute value less than 1. If it's less than 1, convergent. I will put it less than 1 after taking the limit. Okay. So let's write without less than 1 now. So this is after cancellation. Here I will have uh, 1 over n plus 1 times x absolute value. Why? Because after deleting this term with this term, I have n plus 1 here. And after deleting this term with this term, I have x up with absolute value, n positive, n plus 1 positive. X could be negative. So what is the limit of this term? What is the limit when n goes to infinity? X is a constant number, any number, variable, but it's a constant, it's number. So number times 0, so 1 over infinity, it's 0. So the answer is 0. So this number is always, so this is always less than, this is less than 1 for each x. So convergent for each x real number. So the radius of the convergence minus infinity plus infinity. And you can write this interval as 0 minus infinity, 0 plus infinity. So C is 0 and infinity is R. Okay, if you want to write the solution by taking a n x power n, so if you want to suppose a n, it's 1 over n factorial, then write L is the limit of a n plus 1 over a n absolute value. When n goes to infinity, let's calculate this. It's the limit of a n plus 1, it's 1 over n plus 1 factorial over 1 over n factorial. I don't need to write absolute value because it's positive when n goes to infinity. So after deleting, it's 1 over the limit of 1 over n plus 1 when n goes to infinity. So this is 0. So 0 is L. So L equals 0. So using my rule, R is 1 over L. L is 0 positive because this number always positive. So R is 1 over L, so it's plus infinity. So R plus infinity, and here I have x minus 0 power n. So this term, x minus 0 power n. So C is 0. So the interval of convergence is 0 minus infinity, C minus R, and C plus R, 0 plus infinity. So it's minus infinity plus infinity. All the real numbers. Next example, here, this n equal to an. So let's take an plus 1 over an. So it's n plus 1 over n. So the limit of this term when n goes to infinity is 1. This is L. So R is 1 over L equal also 1. What is C, the center? I have here x minus 0 power n. So the center C is 0. So the radius of convergence is 1 and the center of convergence is 0. So we have the interval of convergence is C minus R, C plus R. So it's 0 minus 1 and 0 plus 1. It's minus 1, 1. The last exercise. So here I will suppose this term an, and let's take an plus 1 over an. So this is n plus 1 factorial over n factorial. So after deleting, it's n plus 1. So what is the limit of this term when n goes to infinity? This is plus infinity. This is L, and R is 1 over L. So it's 1 plus over infinity, it's 0. What is the center of, I have x minus 0 power n, so C is 0. So after calculating C and R, so interval of convergence is C minus R, C plus R. So it's 0 minus 0 and 0 plus 0. So here I will because it's only 0 0, so it will be closed. We can take, so I will have only the one number 0. So if I give x 0, I can find sigma. If I give x any number different from 0, this sigma doesn't exist. So if x 0 only, if it's right, if x equals 0, then this the series converges. Series converges. If x different from 0, the series diverges.